Howdy folks, welcome back for another Feature Friday. I'm your host Ryan Glover, and this week we're going to pick up where we left off last week on our conversation about cloud functions. So when we last met, what we were doing is we were utilizing a service called Apex Up. And what Apex Up does is it helps us to simplify the process of creating and deploying cloud functions through AWS Lambda. So if we were to try and deploy cloud functions with AWS Lambda ourselves, it involves quite a few moving parts, and sometimes that can be confusing. And if your goal is just to get a cloud function deployed and working and then kind of move on with your life, Apex Up is a great solution, and it's in my opinion the easiest way to get started with cloud functions. So what I want to do is bring us back to where we left off last week. So at the end of last week's video, I was getting a little tired. And I wasn't really understanding why I was having trouble getting the authentication method to work inside of the cloud function. So right now I'm inside of a cloud function that I built using Apex Up, and this is for triggering the revenue calculation step when I import third-party payment processor data. So in this case right now all I'm supporting is Stripe, but when I import data from Stripe, I want to run that data through a calculation so I can generate the numbers that I'm after. And so the goal was, or is, to take the processor intensive work. So when you're doing calculations, it kind of churns up CPU. It takes a lot of thinking. It's like if I gave you a stack of paper with a bunch of math problems on it and said, here, go do these. That's essentially what's happening to the computer. And we have to keep in mind that we're building with Node.js. And because Node.js is single-threaded, you get into this situation where if you throw too much work at it, it blocks itself, and then you get into this situation where your app just kind of goes to a crawl, or at least doesn't work as well as it could. So the thought with this cloud function is, well, why don't we take that CPU or processor-intensive work off of the main app and put it onto its own cloud function, or essentially its own CPU, or its own set of CPUs. And I say set of CPUs because technically what I'm doing here is I'm going to be, and we can take a look at this, when I call to do my calculations, I do each calculation individually. And so right now on my local machine, this isn't the best example of this, but the idea is that each calculation is going to need access to the CPU to do its calculation, and then we'll move on to the next. So if I do this with a cloud function, the idea is that, well, each calculation is also going to be, and when I say this, I mean in production. So in development, this isn't the case, but in production, this is the case. Each invocation of the cloud function is going to get its own resources, meaning its own memory and its own CPU. So in theory, because it's isolated in its own little box, it's going to run faster. It's going to be able to do the calculation a lot quicker, and it's not going to trip up the overall application. So the flow I have here is that when you import your Stripe data for the first time, I also trigger those calculations for the first time. And ideally, those are as fast as possible, because if you have a bunch of data that we've downloaded from Stripe, doing those calculations might take some time. So the more resources we can give to those calculations and isolate them from other work, the better. So that's the idea here with this cloud function. We're going to call it individually for each calculation that we have. And again, in production, that's going to invoke individual calls to the cloud function. So each of those is going to be put in its own little box with its own memory and its own CPU resources, which is good. So in development, that's unfortunately not the case, but you can still kind of simulate the work and you can simulate the effect. Now, before we go any further, I need to call something out, which is this is not going to be the final solution that I go with, and there's a reason why. So yesterday I was trying to get a calculation to run with a bunch of data. So I think I kind of hinted at this before. There was a situation where small data sets worked fine. They would calculate and run, and everything would do what you expected. But then there was a situation where if I would throw a lot of data at it. So the difference was importing data from Stripe that only went back, I think it was about a month or 2 months, and versus a Stripe account that had 2 years of data. Both would work eventually, but the 2 years of data would take hours and hours and hours and hours. And so after I did this refactor into the cloud function, I started testing this. I noticed that it was a little bit faster for the 2-year one. It definitely went quicker, but it would sometimes work and sometimes not. And it took me a second to realize what was going on, but turns out there's a timeout built into AWS Lambda and by extension Apex Up. So the timeout is, it defaults I think to 15 seconds and it can go up to 25 seconds. And unfortunately this specific task that I'm throwing at it may or may not take up to 25 seconds. It could fit into that window, but it also may go beyond it. And so even though it was frustrating to realize, the point I came to is, well, I'm kind of stuck. So as much as I would love to use a cloud function for this, and I think it is right for the job, the time limits that are imposed based on the tools that I'm using mean that I'm going to get unpredictable results. So I don't want to be saying like, okay, well this is going to work for 3/4 of the users that touch it, but not that remaining quarter. I can't do that. So the final solution, or the solution that I've moved towards, I can't say that it's done yet, but it's almost there, is I've decided, okay, why don't I just build a job server? So we'll get into the details of that next week. I don't want to spend too much time talking about that in this week's video, but that's the end solution that I've gone with. We're gonna look at that and see what I mean by a job server and all that, probably next week, because I should have it done and working and all that stuff. But just know that this isn't the final solution, but I am going to walk you through it because, again, this sort of setup with cloud functions is very smart for tasks that are processor intensive but have a predictable lifetime that's going to fit inside of a timeout. So if you're working on something that has that predictable kind of timeout where you're not, or excuse me, it has a predictable amount of time that it needs to run, and it fits within that window, you're going to be fine. If it doesn't, you might want to look to something else. And again, we're going to look at another solution next week just so you can see kind of how this has evolved, because it's definitely been one of the more difficult things that I've worked on, which surprised me. It wasn't from the technical side as much as it was from the performance side. So writing the code to do the work was pretty straightforward, but getting it to be performant, whole other doozy. So jumping back into our cloud function. So what I want to show you, or what I want to start with here, is how I solved the authentication problem. So if you don't recall, or you haven't seen the first video, and that's linked down below, what was going on was I had this function I wrote called authenticate. And authenticate is stored over here. So authenticate is just a separate function. And all it was doing, it was trying to say, does the app token that the user has passed as part of the request body match the one that we have stored in our environment variables? The problem I was having is that I'm using the Node HTTP package. So this is built into Node.js Core, and it allows you to create an HTTP server. And unfortunately, it doesn't parse out the parameters like a library like Express would. And so I was getting stuck, and I was definitely tired. And it turns out that the way that I had to parse the variables was incorrect. So the way that I solved that, just to close the loop on that, is I said, okay, in this function I'm going to take in the request, and I'm using another package here that I really, really like. It's pretty versatile for this type of work, called query string. So query string allows you to parse and generate query strings. So what I mean by that is a query string is everything in your URL after the question mark. So we'll say question mark test equals 1, 2, 3, 4. So this is the query string. So what that package allows you to do is take that part of the string and say, okay, turn this into an object. So if I parse it, I'm parsing it from a string to an object, and then I forget the method. It's query string. I'm going to forget. I want to say query string stringify. That sounds right. What it does is it allows you to take an object and convert it back to a string. So it's methods for going to and from different formats for a query string. So what I had to do was use query_string.parse on the inbound request URL. So here what I'm doing is I'm replacing the trailing slash that comes in as part of that URL. So basically I get a clean URL that gives me the direct query parameter. So what this is allowing me to do then is pass that value or that URL straight to queryString.parse, which can then read it and say, oh, okay, I see the query parameters on here. Again, this part, so the question mark test equals 1, 2, 3, 4, and then it's going to parse it into an object, which I'm storing in this variable query param. So we take query params in, and we expect there to be an app token, and then all this authentication step is doing is saying, does the app token that they passed in the query parameters match what we've got in our environment variables? And so if, in this case, I've got, let's make this real. So this isn't the URL that I would call, but this will get the point across. So if I passed app token 1, 2, 3, 4, and back over here, app token in my environment variables equaled 1, 2, 3, 4, we would say, yes, this is authenticated. This is what we'd expect. If it didn't, we would return false and it would fail. So the way that that part's working, back up a little bit here. Let's go ahead and save that. Is there's a bunch of stuff going on here. So what I changed was, originally I just had the create server method, and then I was taking in the content or the parameters that I wanted to run my function, and then I was calling my function and just saying response end. That's what I was doing before. Where this has changed is I needed to support a few different things. So I've added the body parser package. So body parser is used for literally parsing the body of an HTTP request in Node.js applications. So typically what you'll do is, if you're using something like Express, you'll use this as a middleware. So you'll do something like not an application cache. You'll say app.use body parser.json, and you'll pass it in like that. Again, that's for Express middleware. But in this case, because I'm doing just the vanilla HTTP package that's built into Node, I'm just storing JSON parser as a function here. So I call to body parser.json, call it here, and what this is going to do is allow me to take in the request and the response, and then you'll notice that it returns a callback function. So in that callback function, I actually handle the request. And you do that because we need to pass the request body through JSON parser so that it can actually parse it as an object. So what I mean by that is, typically an HTTP body is just text, but we want it back as a JSON object. So we want to actually be able to use it in our JavaScript code. So if I do a regular request, it's not going to be in a format that the application is going to understand. But as soon as I pass it through JSON parser, it's going to spit out the other side as an object that I can actually use. And so what I'm doing inside of that function is saying, okay, first, and this is mostly just preemptive. This is me saying, make sure this works the way that you think. So don't assume the happy path. And so the first check that I do is, did we get a request body back? Meaning, did the JSON parser work in the way that we expected, and did it give us what we expected? If it didn't, we want to end the request and say, hey, make sure that you pass these values to us. We need them. So that's one. Two is that authentication check. So we say, okay, we have a body, but is this a valid request? So again, if we go back in here and we say, okay, is the request URL passing us the correct app token? If it is true, great. We're good to go. And actually, this is, let me make sure this is correct. If not, is valid app token. And this is kind of in the mix of me refactoring this, so I had to change some stuff when I converted this to the job server. Again, we'll go over that next week. This does not look correct, though. I think we want, if it's not authenticated. Yeah, because this is going to return true if it is authenticated, false if it's not. So we want to say, yeah, that's correct. So we want to say, if it's not authenticated, then return false and tell them that their app token is invalid. So that's the second step of this. And then the third is where I get into my actual work. And we're gonna leave this kind of on the table because that gets into a bunch of other stuff. But the next thing I do is I actually call to the work that the cloud function is trying to do. So that's the bulk of the configuration over here. And that's all the stuff that we didn't cover last week. So that gets you to the point where you have a cloud function that you can call, and you can call it securely, as well as ensure that you're getting the data that you want. So Now the question is, well, how do we actually utilize this? So what I want to call attention to is over here in my terminal, I'm running this cloud function right now on port 5000. And the way that I'm doing that, as a reminder, is I have an npm script that I run to start the dev server. So this Apex up library gives you the ability to spin up a local server to test stuff out, and it accepts this flag address, so you can say I want to run this on localhost 5000. So the reason I'm doing that is I have my application code running on port 3000, and port 3000 is the default for Apex up, but you can't run two applications on the same port. So I've decided cloud function on 5000, and then I've got my application on 3000. So that's the way that that's working. So now the question is, how do we connect these two together? And so if we, let's save that. If we jump back over to the application code, the way that all of this is working is there's a few different steps. So back in the browser, the user is going to say connect with Stripe. They're going to approve the OAuth request, and then when that OAuth request completes, I'm going to say, okay, let's try and go get their revenue data. And as part of getting that revenue data, what I'm going to say is, well, I want to import Stripe data. Now, there's a few parts before this, but those aren't really relevant to what we're discussing today. Those are putting a job into a queue so that I can run this file that we're looking at here, this module that I'm looking at, import Stripe data. So again, we'll cover stuff like that later because that's going to play pretty heavily into the job server. But for now, just know that, okay, we're going to eventually call import Stripe data, and that's going to call our cloud function. So then the question is, well, when does it call our cloud function? So what I'm going to show you is back down here, as part of this work, what I'm doing is I go through this process and I say, okay, make sure that we have all of the data we need. So I first go to Stripe and I say, okay, download the customer's data, get all of their stuff that we're going to need for our calculations. And then the fourth to last step, I was going to say second to last step because technically that's what it is. This stuff is just basically setting some metadata for me. But this final step, the actual final work, is generate the initial calculations. And like I talked about earlier, that's when we're saying, okay, we've got the data from Stripe, but now we need to actually calculate it so this information is useful. Because in its raw state, it's meaningless. It doesn't mean anything. But once we run it through these calculations, it'll work. So because we're in this current example looking at using the cloud function, we want to call our cloud function right here. And so you can see I'm saying await revenue calculator, and I'm passing the type of the calculation and then a set of options. And this set of options, if we jump back down here, is a product ID, a start date to start the calculations from, and an end date to stop the calculations at. So everything is done inside of a range, and so that start and end date tells me, oh, this is the range you want to pull the data for. And on these initial calculations, I start at the very beginning of that user's data. So the very first chunk of data that I got from Stripe for them, that's my starting point, and my end point is essentially today. So you can see I've got end of today as unique timestamp. So what I'm saying is go to 11:59 p.m. tonight and get all the data from there all the way back to the start of their accounts history. So that's what's going on here. So now we pass that into here, and I've got this function revenue calculator. And so if we look, I'm just importing that up at the top, and that is this file. So this isn't really that special. This is me just kind of packaging this up so I don't have to cram all of this code back into import Stripe data for each of the requests that I want to do. So the idea here is, and you'll notice I'm using a library called Axios. And if you're a Node.js developer and you've kind of been through the paces, or just a JavaScript developer in general, you'll recognize that. So Axios is a library for performing HTTP requests. So http.post.get, .put, and everything else. So what I'm doing here is I'm saying, well, keep in mind, my cloud function is running on another port on the internet, presumably. So in this case, the internet is my computer, so it's on port localhost 5000. So, or port 5000 of localhost. So what I'm saying is, well, I want to call over to that function. So this is saying, what is the URL you want me to call to, or what do you want me to post to? And so I'm not going to show you this because it's going to mean that I got to show you my settings file. But essentially what's going on here is I've got an object in my settings file called functions. And under functions, I've got the different cloud functions that I want to support. So I've got revenue calculator as a function, and then I'm storing where that function lives. And this is environment dependent. So this is what it looks like in my settings development file, whereas my settings production file would actually point to something on the internet. It wouldn't be localhost. So once I get that in, you can see I'm also pulling in that app token we talked about. What I'm doing is I'm saying, okay, we want to post to that URL, and we want to post a few things. So we want to tell ourselves, which calculation are we trying to run? So we look over here and we've got, so in this case, active customers. That's the name of the calculation. And notice that right here what I'm doing is I'm putting this on the body. So the API for Axios.post is you pass a URL, and then you pass your body, so all of your body data, and then the third object is just configuration options, and in there I can set query parameters. So again, I'm setting app token on my query parameters so that I can authenticate the request, or I can say like this is legitimate, because just like any REST API, keep in mind, anybody could technically call this endpoint if they figured out what it was, but that app token is the linchpin. That's the thing that says this is actually coming from me or from us, the application, and not some random person on the internet that we don't want calling it. So what we're doing then, we pass our body. So I'm taking options here, and again, options is all of that data we see down here. So I'm passing this, and I'm combining it with the calculation type, and then we send all of that over. That's it. This is us calling the cloud function. That's the bulk of the work. Now, you may be wondering, like, why did you do it with calculation here and options here and not just combine that into one object? It's just me being a nerd. Really, it's stylistic. Once I did it, I liked this because it kind of told me what I was doing at this point in the code, so I wasn't just saying something like that and then having to remember, like, well, wait, which one was I calling there? Like, yeah, I have the variable, but before I added the variables, it looks something like that, which is kind of nonsensical. It doesn't make sense. So doing that just makes it a little easier for me to understand at this point in the code what I'm doing, and then kind of leads to like the why of like, oh, okay, that's why you're doing that. So I highly recommend that sort of pattern if you're writing code that's repetitive. So if you're calling some reusable function over and over from one file, but then it's actually calling to something else in another file, it helps to think about adding context for yourself. So if you come back to this later, you can kind of understand like, oh, that's what you were up to. So something to consider. So that's how we're calling over to this function, and that's the bulk of it. So the idea is that all we're doing is performing an HTTP request over to our cloud function, and then the cloud function takes over. So as long as we pass the correct data in the body and we pass the correct app token, it should start and it should run. Now, we're going to try this. We'll at least see the request come in, which is the important part here, but I cannot promise that the code is going to work because, again, I've been fussing with the underlying function that's being run here. But let's see. So what we want to do is we want to see some stuff show up here. So each request that comes in, we should see it in our logs. And so what I'm going to do is jump back to the app, and we're going to connect to an account. And this is my smaller data set. So I'm going to connect that, and we're going to let it run. If we jump back, that was pretty quick, we can see that our post requests all came through. So it did try to run the cloud function. Now, whether or not it actually did, no, it didn't. So my data's all messed up. You can see I'm getting null and no chart at the moment. But the important part being that this code works. So it ran through the process of downloading the data, and then it came finally to the point where it had generated initial calculations, tried to run it, and pass that work off to the cloud function here. So it came in here and attempted to run it. So that's it. That's the basis of using cloud functions, or putting a cloud function to use, however you want to think about it. It can sound more complicated than it is, but again, the idea is that you're just basically creating, in so many words, an employee for your application to go do that work. So if you're personally overwhelmed, you have too many tasks, meaning your application, you can hand that off to an employee in the form of a cloud function to say, hey, can you help me with this and knock these few things out? And so that's the idea here. And so again, what's cool about this is cloud functions have their own resources. So again, just like a human would if you ask them to go do a task, they have their own physical energy and brain power and all of that stuff. So they're able to take on tasks that are overwhelming you. Same exact pattern with this pattern between an application and a cloud function. Application's getting overwhelmed, hand some of that heavy lifting off to the cloud function and let it take care of it. Again, the big gotcha there is timing and making sure that you're not doing work that's going to potentially go past a timeout. So if the work that you're doing is predictable, it's just processor intensive, highly recommend putting it on a cloud function and taking advantage of the cost savings and the headache savings, because ultimately when you're doing these, it can really drive you nuts trying to make something performant, because it looks like you're doing the right thing and you are doing the right thing in terms of your code, but when it comes to performance and things like that, you always got to keep in mind a computer only has so much energy. So I think that's going to do it this week, folks. Hopefully that was informative. Hopefully that gives you some ideas for how you can restructure your own application to be a little more performant and cause you a little less stress when it comes to getting things to run as quickly as possible. So thanks for watching. As always, if you haven't already, make sure to hit the subscribe button down below and tap the bell right next to it. That way you're going to get notifications as soon as these are released each Friday. So thanks for watching. Signing off for the HMS Beagle. I'll see you next week, folks.